Hi, welcome to my video on part 6. Find the value of a trig ratio given a radian. So, radian as a decimal to the nearest hundred. Use the calculator with the radian mode. So, let me explain. I'm going to use my Textures Instrument calculator and I'll turn it on. But what I want to show you is that right here is degree, radians, and gradient. Right now it's underlined as degree. So if I shift that, it'll go to radiant, gradient. But I want the calculator to be in radiant mode. So I hit enter. So now the calculator is in radiant mode. I'll remind me to keep it in radiant mode. Now it's in radiant mode. So if we look at the cos of 1, notice there's no degree symbol here. So 1 is a radian, 2.7 is a radian, -5. These are all decimals, but there's no degrees, so they're understood to be radiant. So if I'm going to use a radiant that's in decimal mode, then I would use my calculator. So if I use my calculator, I'll hit cos of 1, and that'll give me decimal 54 to the nearest hundred. So that's 0.54. And now I'll do the cos of 2.7. So cos of 2.7, and the answer is -0.90. This is less than 5, so it's 0 won't change, so it's a -0.9. -0.9. And now I'll do the sine of a -5. Sine, and we'll make it negative. This is a subtraction. Negative is right here. -5. And we have, notice, 0.958. 8 is larger than 5, so we decimal 96. So 0.96. And we'll do the tan of 3.62. The tan of 3.62. So we'll hit tan on the calculator, and we'll go 3.62 and close it in, and we get 0.518. 8 is larger than 5, so it's 0.52. So 0.52. Now we have the secant of 4.9, and the secant is 1 over secant s, so I need a c, so secant is the reciprocal of cos of 4.9. So I take the calculator and I can clear what's there, and I can do 1 division, and I get the cos of 4.9. 4.9, close it off, and I'll have 5.36. So 5.36. And notice I'm in radiant mode. I'm going to repeat that. I'm in radiant mode. And we're doing the cosecant. Cosecant is 1 over, that's a c, so I need an s, so that's a sine of -0.6. So bring back the calculator, and I'll do, clear that. I get 1 division, and that's sine of, and I just look again, 0.6, -0.6, or just 0.6, and I'll get -1.77. -1.77. And notice we're using our calculator in radiant mode because take my calculator away. Again, we're going to practice now. So pause the video, see if we can work these out. So notice the 2, negative 4.95, 3.74, 5.3, negative 2.44 are all radians. We're cos, sine, tan, secant, cosecant. We're doing it in terms of a radian. So we have to have our calculator in radian mode. And you can, I don't know if you can see, I have the radiant is right here, but I just check again. Notice it's in radiant mode, so everything is okay. And we'll just turn that off and get rid of it. Let's turn it on again. So we know it's in radiant mode. So I'm doing the cos of 2. The cos of 2. Here we go. Cos of 2. And the cos of 2 is negative 0.42. 6 is larger than 5. 6 is larger than 5, so I make the 1 a 2, add on 1. And now we do the sine of a negative 4.95. So sine of it, that's a negative 4.95. And we hit enter, and we'll get for that 0.97. 1 is less than 5, so the 7 stays as it is. And the tan is the tan of 3.74. Tan of 3.74. Tan 3.74. And that gives us 0.68. So that's 0.68. And this is fairly simple because you're only using your calculator, but you have to be in radiant mode. The cosecant is 1 over the sine of 5.3. That's a C, so I need an S. So 1 over the sine of 5.3. We clear that. We go 1 division. And we're doing sine of 5.3, close it off, and we have negative 1.20. Put the 0 there, but we don't increase the 0 because this is less than 5. And we have one more to do, the secant. I'll put the calculator up here. The secant is, we set 1 over S, I need a C, so it's a cos of 2.44. And I plug that in my calculator, and it's, I'll just see it again. 1 division cos negative 2.44, and there it is plugged in. We hit enter, and we get negative 1.31. 9 is greater than 5, so we add 1 onto the 0. And notice when we're doing these, we close it off. We close it off with a bracket. The only reason we close it off is so when I do the cos of this, I put a bracket around the radiant measure right here. Okay, that's when the radian is as a decimal. We did the trig ratios of it. That's not too hard to do. But remember, we're in radiant mode. Now, let's do a radian in terms of pi. Find the exact value of each. Notice that each of these have pi in them. So we have to work it out in terms of pi. Well, you can do it with a calculator, but let's do it without the calculator. I'll do it with the calculator just to check also. So what I do, pi over 4, and pi over 4 is, pi is 180 degrees over 4. So that's the cos of 4 and 180 is 45. So I'm working on pi over 4 is 45 degrees. Notice 4 is in your denominator, so this is your Also, this is your reference angle. So if I draw a circle, like have a circle drawn, here it comes. I start from this point right here, which is 1, 0, because the radius of the circle is 1. And I plot 45 degrees on the arc. So there's 45-degree rotation. The terminal arm goes up to there, and we drop a perpendicular to the x-axis. So this angle is 45, the reference angle. So this angle is 45 also. And so the triangle has, notice the radius is 1, so the hypotenuse is 1. So this side here is root 2 over 2. And this side right here is root 2 over 2. And cos is the x, and the x is along here, so x is root 2 over 2. Now, if you use your calculator, now, one thing we got to remember is that my calculator right now is in radian mode, so I can work this out. Let's see what happens if I use my calculator. I won't get an exact, so let's do the cos of pi on my calculator is right here, division 4, close it off. Now, see what happens. Decimal 7071. 7071 is the same as root 2 over 2, but 7071 is an approximation. It's going on and on because it's irrational. Now this is in radian mode. So what I want to do is I'm going to always work it out. So what we should do and remind us is that we should have our calculator in degree mode all the time. Only change it to radians when you need to. But as soon as you have it in radian and you're finished, change it back to degree mode because everything works in degree mode better. So let's clear this. So let's do the cos of 45 because we're in degree mode now. 45 degrees, same answer. So if I had the radian at pi over 4, I need to be in radian mode. If I have 45 degrees, I need to be in degree mode. But root 2 over 2 is 7071. So let's check. Clear that. Square root. Let's do the square root of 2. And notice I closed it off. Division 2. And we're right. So root 2 over 2 is the exact value. Okay. So let's put the calculator away here. Now let's do some more examples. So we don't want pi, because I like to work in degree mode. So pi is 180 divided by 2. So that's the sine. That's a 90 times 3. So that's the same as the sine of 270. So 270 is on the circle. Remember the point is 1, 0. So 270 is right around, right to here. So this point here, remember the center is 0, 0. So this point here, x is 0, y is negative 1. So the sine of 270 is the y. Sine is the y. So it's a negative 1. And if you use your calculator and do the sine, remember we're in degree mode. We're doing the sine of 270. Just check it out. Negative 1. Okay, so you can use your calculator to check. But the calculator worked great with sine and cos, and but with secant and cosecant and cot and tan, you got to be careful because you might not recognize the decimal forms. So the cos of negative 2 pi is 180 over 3. So that's the cos. And notice the pi over 3 is a 60. So 60 times 2, it's negative 120. Notice pi over 3 is the reference angle. Pi over 3. Notice pi over 4. The reference angle is 45. And I knew that I would have a 45-degree angle here. So the reference angle here is right there. Pi over 3, 60. So I'll have a 60-degree reference angle when I draw this circle. So here's the circle. So I'm plotting out negative 120. So negative 120, negative 90. I'm over right here. So that's the negative 120 rotation. Terminal arm, perpendicular to the x-axis. So that's the negative 120. This part of the arc here is 60. So that means the reference angle is 60. And I knew pi over 3 is the reference angle, which is 60. So I knew when I stopped, did my rotation in this third quadrant, I would have a reference angle of 60. So that's 60. This is 30. Opposite 30 is a half. Opposite 60 is root 3 over 2. And the x is negative, and the y is negative. And the cos is the x. Again, it's a negative a half. Use your calculator and check in degree mode. Cos of a negative 120 should give you a negative a half. Now we're doing the tan. And again, pi over 6. Pi over 6 is 180 divided by 6 is 30. So the reference angle is 30. Keep that in mind. So this is 5. And pi is 180 divided by 6. So 180 divided by 6 is 30. 5 sixes. So that's the tan of 150 degrees. And let's draw the circle. Keep in mind, the reference angle when I'm finished is going to be a 30. 180 divided by 6, there's your reference angle. It's 30. So 150 on the circle, and you're rotating from this point right here. 150 is 90, and there it is, 150. So what's left over when you draw your terminal arm? That's a 30 right there. There's 180 all the way around to here. So that means the reference angle is 30, perpendicular. That means this angle here is 60. Opposite 30 is a half. Opposite 60 is root 3 over 2. And notice the x is negative and the y up here is positive. So the x is negative. So tan is the y over the x. So the y is negative a half. And the x is root 3 over 2. So now I'm going to simplify that over here. So that's negative a half times 2 over root 3. Because when you divide, you multiply by the reciprocal. The 2's cancel out. So I get a negative 1 over root 3. Not allowed to have a radical in your denominator, so you multiply by root 3 over root 3. So that gives a negative root 3. 1 times root 3 is root 3. Root 3 times root 3 is root 9, which is 3. So there's the exact value for the tan of 150. And let's continue. The secant of 5 pi over 2. The secant of 5 pi is 180 divided by 2. Notice that's the secant. 180 divided by 2 is 90, so 5 times 90 is 450. So 450 is a big rotation. So let's take the 450 and subtract 360 from it, and we'll get a 90. So that's the secant of 90. 450 is around plus 90 more. But if you do the secant of 450 or the secant of 90, you only got, when you do 90, just rotate to here. So you can do either one. And the secant of 90 is 1 over the cos of 90. The secant is the reciprocal of cos. And on the circle, again, 1 comma 0 unit circle. 90 degrees is right here. There's 90 rotation right to here. So x is 0, y is 1. So 1 over the cos of 90. The cos of 90 is the x, cos is the x. So that's 1 over 0. And 1 over 0 is undefined. No answer, because you can't divide by 0. Okay, that's some examples when we use radians. But notice we changed the radians to a degree and work everything out like I did before. without the previous videos when we're working with angles. Find the exact value of each. Okay. The cosecant of negative is the cosecant. Let's change negative 3. Pi is on, we're going to put pi back again. 180 divided by 4. And so that's the cosecant. 180 divided by 4 is 45, so that's a negative 135. And the cosecant is 1 over the sine of negative 135. And so let's draw the circle. I always like to draw it out. And a negative 135, again, the point that we're rotating from is here. Negative 135 is right here. That's negative 135. Notice pi over 4 is a reference angle. So after I draw my terminal arm, set up my right triangle, I know that the reference angle is 45. Well, let's check it. If this is 135 as far as here, this is a 45 right here on this arc. That means the central angle is the same. So we have a 45, 45 right triangle. The hypotenuse is 1, and the legs are root 2 over 2, root 2 over 2. But the x is negative, and the y is negative in this quadrant. So we have 1 over the sine is, both of them are the same. Sine is the y, which is a negative root 2 over 2. X is negative root 2 over 2 also. So that's 1 times 2 over negative 2 over root 2. And so that gives us negative 2 over root 2 times root 2 over root 2. So that gives us negative 2 root 2 over 2. And they cancel, 2's cancel, and I get a negative root 2. So a little bit of work, but notice if you draw the diagram, everything works out okay. And now we're working out the sine. Remember, you can pause your video and work these out. So pi is 180 divided by 6, that's 180 degrees. So that's 6 into 180 is 30. So that's the sine of 210 degrees. And again, let's draw the circle. Rotate 210 degrees. So 210 is 90, 180, and 30 more. There it is roughly right there. Terminal arm, perpendicular to the x-axis. So that's 210. So that means that this is 180, this is the 30. That means this reference angle is 30. But I know that the reference angle is pi over 6. 180 divided by 6 is 30. I knew I was going to get a 30 reference angle. And that's a 30, this is a 60, so opposite 30 is a half. Opposite 60 is root 3 over 2. And the x is negative in this quadrant, and the y is negative. And the sine is the y, so the y is negative a half. Sine is the y, negative a half. Because the hypotenuse is 1, because this point is 1, 0, the radius of the circle is 1, making the hypotenuse 1. Now we have the tan of 180 degrees divided by 2. That's the same as the tan of 90. And when we draw our circle, and we do a rotation, 90 degrees from here, remember that point is 0, 1, 0, and we rotate to the 90 here. So this point, the center is 0, 0. So x is 0, y is 1. So there's the 90 degrees. Tan is the y over the x, and the y is 1, and the x is 0. So 1 divided by 0 is undefined. Tan is undefined for a 90 degree rotation. And we have the cosecant of negative pi over 3. So that's the cosecant of negative 180 degrees divided by 3. So that's the cosecant of negative 60 degrees. And notice the reference angle is pi over 3, which is 60. So let's draw a negative 60. Here's the circle. And again, this is the point 1, 0. Radius is 1. So negative 60 is this way right here. So let's say that's negative 60 or negative pi over 3. Terminal arm to the x-axis, perpendicular, or terminal arm passes out to the rotation. We drop, that's a 1, that's a perpendicular there. And so this is a negative 60, so the reference angle is 60. And this angle is 30. So opposite 30 is a half. Opposite 60 is root 3 over 2. The x in this quadrant, fourth quadrant, the x is positive and the y is negative. So the cosecant is 1 over the sine of a negative 60. And the sine of a negative 60, sine is the y, which is the negative root 3 over 2. So that's 1 times negative 2 over root 3. So that's negative 2 over root 3 times root 3 over root 3. And that gives us negative 2 root 3 over 3. Root 3 times root 3 is 3. Root 3 times root 3 is 9. And so hopefully everything is going okay. So the cot of negative pi is negative 180. Pi is 180. And so we draw the circle. And we do, again, the point that we're rotating from is 1, 0. Radius is 1. So we're going a negative 180. So that's right to here. And this is a quadrantal angle. Any angle that ends up at 90, 180, 270, or 360, or 0 are quadrantal angles. So this point right here, x is negative 1, y is 0. So the cot, tan is the y over the x, so the cot is the x over the y. So the x is 0. Sorry, my mistake. The x, that's the x and the y. I better be careful. So the x is negative 1, and the y is 0. Again, undefined. Let's just have a look at I just come up with this. What about the tan of negative 180? Well, the tan is the y over the x. So the y would have been 0 over the x, which is negative 1. So the tan of negative 180 is 0. 0 divided by negative 1 is 0. I just want to check that with a calculator. The tan of negative 180. Remember, the calculator is in degree mode. Perfect. And I'm doing the tan of a negative 180. And we get 0, which is what I have here. The tan of negative 180 is 0. And if I do the reciprocal, the cot is reciprocal of tan. So therefore, if tan is 0, cot is 0 over 1, the reciprocal. So tan is 0. Tan is over 1. So cot is a negative 1 over 0, the reciprocal. So the reciprocal of 0 is undefined because it puts the 0 on the bottom. Okay, just a review. Just going over, making sure. Change your radiant to a degree and work in degree mode. Noticing the reference angle. And if you like my video, click the like button, subscribe button, and visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.